Hello, National 5. This is angles in a semicircle. So we have some questions from the exercise that's been set. So I want to go over a couple from 1 and 2, a couple each from 1 and 2. Let's have a look at 1A. So the important thing to know with this exercise is that if we have a semicircle, the angle opposite the diameter is always 90 degrees. Always 90 degrees if it is opposite the diameter. So here we have a whole circle. It's been cut in half. So this line here will be the diameter. Opposite the diameter, the angle will be 90 degrees. Now after that, we've got a triangle. There are 180 degrees in a triangle. So 180 minus 90 minus 60 will give angle A, and that turns out to be 30 degrees. Let's have a look at 1D as well. So in 1D, again, here is our diameter. So just looking at the top triangle here, so ignore this triangle, pretend it's not here for a minute. Let's look at this triangle. The angle opposite the diameter will be 90 again, so only looking at this triangle, I've got 90, I've got 56. I know the third angle, when I add it to the 90 and the 56, will make a total of 180 degrees. So I'm going to do 180 minus 90 minus 56, which is 34 degrees. And now I'm going to look at the bottom triangle. So essentially I've got two questions in one here, so I'm doing them totally separately. Again, I've got the diameter, opposite the diameter, I've got 90 degrees. I've got 42 here. So 180 minus 90 minus 42 is 48 degrees. So let's have a look at a couple from number 2 as well. So I've got 2C here again. Here is the diameter. Opposite the diameter, we'll have 90 degrees. Now I've got these little dashes. These little dashes mean that these sides are equal. They might not look equal in my diagram. In the question, they're equal because I've got the dashes on. So that means that these two angles here must be equal. So I know if I got one angle of 90, then the other two must also add up to 90, because 90 add 90 is 180. So if I half those, they'll be 45 each. Could double check, 45 add 45 90. Add the other 90 is 180. Now here I can add in these angles as well. So I've got a straight line here. So going back to our S1 knowledge, so angles on a straight line add up to 180 degrees. So if this angle is 45, this angle must be 180 minus 45, which is 135 degrees. And this angle, in a similar way, is also 135 degrees. So if I was doing one of the questions where I'm given this angle first, so I think there's one, it might be 120 or 130, I would be thinking, well, I've got a straight line, so I can work out the missing angle on the other side of this. Okay, and let's have a look at one of the later ones. And I haven't written the answers down, but if you guys copy out the question, I'll talk you through how to get to the answers. So I've got 63 here. I've just labeled all the angles I'm going to look for. So we have, first of all, we know this large angle, so Z and Y together. This angle is 63. We have a triangle. We have the diameter here. So this angle is 90 degrees. So I'd get that angle in first. We also have another triangle made with the diameter of the circle. So this angle here is also 90 degrees. Okay, so I've got those two in first. Very important that we spot those 90-degree angles. Then after that, well, this large angle is 63. So just looking at this triangle here, this one here, 180 minus 90 minus 63. So that means angle X will be 27 degrees. Now looking at the other triangle, here, so X is 27, this other angle is 29. So that large angle, which is part of the other triangle, will be 29 plus 27, which is 56. So I've got 56 degrees, I've got the right angle, and I've got angle Y. So that would make angle Y 180 minus 56 minus 90, which is 34 degrees. Again, we're just looking at that triangle only. So if Y is 34 and Z and Y together make 63, then Z must be 29. Okay. And then here, if Z's 29, this is a right angle. So here I'm looking at this smaller triangle.